After this video, please watch the notes posted in Google Classroom. These are notes for Lesson 3.4, Measure of Dispersion. So previously we learned about central tendencies, or what marks the center of a data set. We got mean, which is the average of all the points of data. We got the median, which is the center point if you listed out all the data points in order and looked for the exact center. And we have mode, which is the most common number in the data set. But the center of the data is not the whole story. There's how far it's spread out, how far it stretches, and where all the data is clumped. So we're going to talk about first how far the data is stretched out. I'm going to start with these three data sets. One which is pretty much clumped in the center but has a couple extremities, others that are just clumped together, and one that is just spread out a lot. Turns out the mean of all these data sets is 5. And when you look at that, the median for all these sets is 5. And you guessed it, the mode is also 5. These three data sets are vastly different but have the same central tendency. So the first way we can see is how far they are stretched out from the lowest point to the largest point. So we found out the range for each one of those data sets. And that does tell us they're spread out. But what does it not tell us? Well, it doesn't tell us what's happening inside the data. It's just looking at the outsides of it. So what if we knew how far each point was spread from the center? And the center we're going to pick in this one is the mean, which is an X with a little line over it. So let's start with the summation of the number minus the average and divided by n. By adding all those up, we should find out how far each point is from the mean. I then wrote the English translation of the math term on the side. So for starting with data set 1, I'm going to have the data set, I'm going to have the mean, and then the difference. Those are going to be my 3 columns. Data set's pretty easy, I copy it over. And the mean's even easier because it's the same number for all of them, and we stole that from the previous page. Then we subtract all those, we get a 5, 3 zeros, and a negative 5. We add them all up, and we divide them by the number of items in our data set, so we have 0 divided by 5, which is 0, and we're done. That 0 doesn't seem very descriptive, so we try another data set 3. Do the same thing, set up the 3 columns, I add them all up, and I get 0 again. Turns out, if we try to find the distance from the median of all these and add them all up, well, by definition of the average, it's always going to be 0. So math came up with a different way of doing it, which is by getting rid of the negative signs, and by doing that by using squares. So this new formula is a little uglier. So variance is actually referred to as s squared. It's equal to the sum of those distances before, but this time we're going to square them, and we're going to divide the whole thing by n minus 1. And the symbol on the right side is also another way of writing the word variance, and that will be discussed later in the book. So it's the sum of the distance from the mean squared divided by a magic number. Now, it's n minus 1 because there's some quirky things that happen later, referring back to true populations versus sample populations, but right now it's n minus 1. So I made a chart for the first data set where I found the numbers, the average, the subtracting the number from the average, and then squaring that. I added them up, divided by 5 minus 1, and it gave me 12.5 as my s squared, or my variance. I repeated the process again with data set 3, so I can compare it to the data set 1 that we did earlier. When I add them up, get a slightly bigger number, like 1,000 bigger, and divide it by the same 4, and I get 262.5, which seems a lot more spread out than the first one. Data set 2 was much more clumped together than the other two, and so it should have a smaller number. Yes, 0.5 seems to be much smaller than 12.5, which means much more clumped together. So there's also a second formula for variance. While this formula looks way uglier than the other one, in some situations it's actually easier to use, and you can use either one depending upon what method you want to use at what time. And while they look different, they always will give you the same answer. This all leads us to standard deviation. Standard deviation is the actual tool that we use to find how spread apart data is. because we can use these for normal distributions and other stuff that will be represented later in this chapter. The formula for standard deviation is, well, actually it's just the square root of s squared, which is s, which means standard deviation is s, which means all that stuff we did before was actually relevant to what we're doing now. So here's a new data set with some numbers. I add them all up and I get 199. Next, I'm going to square all those numbers. I add all those numbers up together and I get 13,319. First, the mean for these numbers is 24.875 because we took the 199 and divided by 8 since there are 8 numbers there. I'm going to find the variance, but I'm going to use the formula, the alternate formula given later, and I plug in all those numbers that I've already found. And to find the standard deviation, I just take the square root of 1,195.55, and it gives me 34.576. So let's make a quick chart or graph so we can see where the data lies and what it's telling us. The numbers on this chart were picked specifically. First, the middle number is 25, which was the simplified version of the mean. Then each hash mark after that is 35 away, which is 1 standard deviation. When I plug in all the data points, we notice there's 1 point in the middle, there's a lot of points on the left side, and a couple points on the right side. They're just filling up space. And then for some reason, I lost my last slide, but here's the full page instead. Their numbers are shown 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away, which will definitely be more important next section. And that's it for the notes. Please answer the question at the end of the video.